And at this point, I'd like to take this moment to introduce Bill to you. Bill is the chairman of the Colorado Pilots Association Mountain Flying Program. He's been doing the program teaching for about 30 years. He's also an instructor in the aviation department at Ames Community College. He's a member of the Civil Air Patrol and also a fast team rep. He's also with the Civil Air Patrol, he's a check pilot or a mission pilot and a check pilot. So he's of the Northwest Mountain region. So Bill, on behalf of the FAA, we'd like to say thank you for being here today and a certificate of appreciation. Thank you.
Okay, good morning everybody. Welcome to Oshkosh. It's the first time I've done this on a Monday, so it's interesting to see how the crowds change during the week. Again, I'm Bill Standerfer. I'm the chairman of the Colorado Pilots Association Mountain Flying Program, and we've been putting on a program in Colorado to try and reduce the accident rate. A lot of people have crashed in the past, and we're trying to stop that. So we put the program together about 27 years ago now, and we've been teaching, and we taught over probably 1,300 pilots. So if you're coming out to Colorado or out to the west, whether it's Colorado or any of the mountains out there, and you haven't had a mountain flying course, I strongly recommend that you get a mountain flying course. If it's not ours, that's fine. Find somebody and get a good, solid mountain flying background before you go fly. So today what I want to talk a little bit about is flying in Colorado mountain flying in weather. I've taught this, I had this seminar several times in the past several years, and so I thought today I'd try and focus a little bit more on weather and talk about some of the weather factors that affect Colorado mountain flying. And again, I talk about Colorado mountain flying, and we do that because a lot of the problem that people have is high density altitude. But the kind of things we're going to talk about apply to any mountain range, whether it's the Appalachians or the Sierra or the Pyrenees or whatever it is. The difference in Colorado is we have pretty high density altitude, and we'll talk about that. So it's a pretty place to fly, rugged mountains, and so you really need to get some good training to tackle these mountains. So this is my favorite place to fly. Colorado's got such beautiful scenery, and we'd love to have you come out and join us to take a look at it. But the topography is a problem. We have 54 peaks over 14,000 feet, and we have over 600 over 13,000 feet. So Colorado's a pretty high place. We have very few airports that are under 5,000 feet. Most of our airports are 5,000 and above. And then we have the highest public use airport in North America at Leadville at 9934. So again, lots of places to get into big trouble if you don't understand density altitude. There we go. So I want to talk a little bit about flight preparation first. Flight preparation is really important. You need to look at, need to get a good weather briefing, but you also need to look at things like NOTAMs and TFRs. You want to check for alternate routes. When I get a weather briefing for Colorado to go up into the mountains, normally out here you can get the normal 50-mile corridor, whatever it is that DUATS and LIDOS gives you when you do a flight plan. In Colorado, what I wanted to look at is pretty much a statewide view of what's going on. Because if one pass is blocked, you may have to go a long way out of your way to be able to find some place you can go over safely. And so I get a much wider view of the world when I do a briefing for flying in the mountains. You also need to be aware of the national security events and the TFRs and so on. Now, obviously, you have to do that out here, but because of the constricted terrain and so on, you have much less option of, if somebody puts a TFR up, much less option of finding a way around it. So you may have to go way out of your way to make that happen. Also, we want to look at the winds aloft forecast from 9 and 12,000 feet. That's usually the best place to look for the winds aloft for the altitudes that we're flying out in Colorado. And look at the ceilings en route, and we'll talk about that here in a little bit. So, For winter operations especially, a lot of people like to come out and go skiing in Colorado. So winter operations presents their own little problems. So you need to look at NOTAMs and make sure that the airport you're going into has the services that you need for your aircraft. A lot of places you can't park the airplane. You go into Aspen, and a lot of times I've heard on the ATIS, no single-engine piston aircraft, no parking for single-engine piston aircraft. So during the ski season, it's very crowded up there. Aspen, Eagle are especially crowded, and so you may have to go somewhere else. And if the weather's bad, I recommend you go somewhere else anyway. You go into places like Aspen or some of the other places. Some of the other places are smaller airports: Glenwood Springs, Rifle, Hayden, some of those places. They're smaller airports, and so they don't have a lot of tie-down space. So you need to check and make sure. Call the FBO up and see if they've got the services you need for your aircraft. Also, look at a long-term view of the weather forecast. The mountain weather can change pretty quickly, and a lot of times it stays around for a long time. So we might have snowstorms up in the mountains that last for several days. Make sure you don't get caught up there. Maybe best just to go to Grand Junction or go to Denver, rent a car and drive up there. A lot of times that's the best choice, especially in the wintertime. So avoid getting trapped up there with IFR conditions. A lot of times these small airports don't have engine heaters or other services that you might expect. My parents used to live in Glenwood Springs, Colorado, and I went up there once when we lived in California. Went up there once, and we went to leave, and the Seneca we happened to be renting at the time wouldn't start. Well, Glenwood doesn't have a ground power unit to start an airplane. So the FBO guy brought his car over, and we finally got the airplane jumped, and we got the airplane got it going. But if you have a problem like that, you can't depend on that those kinds of services being there. These airports are small. A lot of the airports are small and simply don't have the equipment you might need if you have a problem. Also, a lot of them don't have A&P service. So if you think you've got an airplane problem, you might want to check ahead and land someplace that has somebody that can help you out. And as always, I'm going to say this a couple of times probably, if in doubt, park the airplane and rent a car. That's all. I say that's always the safest route, but if you've ever driven Interstate 70 going up to the ski areas, maybe that's not necessarily the safest route. Here's some NOTAMs of interest. This is from a couple of years ago during a snowstorm. And these are the kind of NOTAMs you want to take a look at that you often don't see out here. First one at the top, we were having a blizzard in Fort Collins. Airport was closed. Okay, that pretty well tells you what you're going to do. But also look at what are called FICON. What is FICON? FICON is field condition reports, field condition NOTAMs. And if you look at, let's see, did I put them in here? I guess I didn't put them in here. Oh, yeah, basically right in here. It says FICON, that's field condition. And what that's telling you is what's the condition of the surface of the airport. So in this case, we've got Granby is closed, GMB is closed, Glenwood Springs, 5-foot snowbanks adjacent. Okay, how tall are your wings as you go down the taxiway? Aspen, all surface markings obscured. Aspen, runway 15, signs all obscured. Runway 33, signs all obscured. 2-inch dry snow over ice. How's your braking action on 2 inches of snow over ice? Probably not great, right? So check the NOTAMs and make sure that you can handle what you're getting into. Up there, a lot of times midwinter, mid to late winter, it's snow and ice on the runway and taxiways. And so you had a plan for that. Also in the summertime, this time of year, we have a lot of forest fires. We don't have so many in Colorado right now. about 4 years ago. And you can see all the TFRs. Every one of those is a fire, a forest fire. And the airplane up here, that's where I live. This one right up here. That's on just north of Fort Collins, Colorado. When I took this shot, this screen grab, the visibility at my house was a 1/4 mile in smoke. We had about a 10,000 acre forest fire just west of us. All the rest of these, I mean, this was a really bad year for Colorado. Everything was burning up there. But the point is, the visibility was awful. It was really not a good time to go fly in the mountains in Colorado. So check the NOTAMs, or check the visibility, check the TFRs. Now also, we get smoke from everybody else that's burning to the west of us. We were up there a couple of weeks ago, and the visibility was not great because we were getting all the smoke being blown in from California and Arizona. So check the visibility and make sure that it's something you can handle. And we'll talk more about visibility minimums here in a little bit. We also have some unusual TFRs occasionally. This is probably not something you see in Missouri. This is a TFR for avalanche control. Now in Colorado, for avalanche control, one of the things they do is they have a small howitzer, and they shoot live ammo up into the avalanche area, and they explode. Okay, I don't want to be around. It's a live fire area, so pay attention to these. Probably something you don't see very often out here. Also, probably something you don't see around here is something like a sign like this. This is at Centennial Airport in South Denver, and it's about. I'm guessing this is in probably the way the sun mid-July, and the density altitude is 7,322 feet, and it's about 8 in the evening, probably just before sunset. So it's been hot. And the density altitude is still about 3,000 feet above the ground. Okay, so the idea is to fly early in the morning before the density altitude gets this high, but also remember that later in the evening it takes a long time for things to cool off, and so remember we've got high density altitudes out there. Centennial is at 5,600 feet, 5,630, something like that. I forget what the number is. So we've already got a density altitude that's a couple thousand feet above the surface. Still, in the evening, in the late evening, when you expect things to be cooling off. So keep that in mind when you come out west. It's not just Colorado, but you'll see this at Jackson Hole and other places as well. So a little bit about density altitude. You can't get away from here without me talking about density altitude at least once. It is so important in mountain flying out west. First of all, density altitude. Think of a standard day, an ISA standard day, 59 degrees Fahrenheit and 2992 inches of mercury at sea level. And the temperature decreases 0.6 degrees per 1,000 feet as you go up. And the pressure decreases at about an inch per 1,000 feet. Okay? If the temperature is above standard, the density altitude is above field elevation. It's basically all you have to think about. If it's a temperature above a standard day, then the density altitude is above field elevation. So let's look at what standard temperature would be at various altitudes. So we start at sea level, 59 degrees. If we go to 5,000 feet, that's most of the front range airports in Colorado: Denver, Fort Collins, Greeley, Centennial, Jeffco, the airport formerly known as Jeffco, Colorado Springs, and Pueblo. A standard day is 41 degrees. So when it's 85 or 90 degrees outside, density altitude is pretty high, even before you get to the mountains. Everybody thinks Denver's in the mountains. Denver is not in the mountains. If you haven't been there before, Denver is not in the mountains. Denver is on the plains. It's flat. Okay? Now we get to Leadville at 10,000 feet. A standard day is 23 degrees. If the snow is melting at Leadville, the density altitude is above field elevation. Okay? If the snow is melting at Leadville, the density altitude is above field elevation. Okay? So at Leadville, a 63-degree Fahrenheit day, 40 degrees above standard. Density altitude will be 12,500 feet on the ground before you start the prop. So think about how your aircraft performs at 12,500 feet and consider taking off at that altitude with that performance. So in a non-turbocharged airplane, you're taking off basically at cruise altitude or cruise power setting. So how's your airplane perform? What's your climb rate? Right? A rule of thumb, it's a very rough rule of thumb, but rule of thumb is if it's 85 degrees on a front range airport that is still out on the plains, it's 85 degrees Fahrenheit, the density altitude is about 8,500 feet. So right now, today, at Fort Collins, where I'm from, the density altitude is about 8,500 feet. That's just a normal summer day for us. So if you haven't experienced that, please go with an instructor, get some instruction, and understand that under safe conditions, and then go to the mountains and really understand it when you go to the really high places. Okay? So effects of high altitude on aircraft performance. Normal aspirated engines develop about 3% less power per 1,000 feet as you go up. About 3%, which means that at 10,000 feet, you're taking off in a normally aspirated engine with 70% power. Okay? So cruise are a little bit lower than max cruise power. True airspeed is about 2% higher than indicated airspeed for every 1,000 feet. The complication comes in that your turn radius is proportional to the square of true airspeed. So normally you're flying at the same indicated airspeed at all of these altitudes. So if you fly final at 80 knots or 70 knots, you fly final at Leadville at 75 or 80 knots, whatever the number is. Just remember that your true airspeed is going to be 20% faster. Your turn radius is going to be greatly exaggerated. So what do you do at Leadville? Flying the pattern. You fly it a little bit wider. When you get down close to the ground, you fly the same indicated airspeed, the same pitch attitude, but the world is going by a lot faster. Don't let the visual cues from the high density altitude get you messed up. A lot of people want to rotate too quick because they see the trees going by really fast. Same indicated airspeed. Okay? And then obviously takeoff and landing distances are significantly increased. The aircraft, especially normally aspirated airplanes, the performance, the takeoff and landing performance is going to be dramatically longer. Now most of the airports, our mountain flying course is not a backcountry flying mountain course. We don't have a lot of backcountry flying places in Colorado. Now, there's a group that's trying to help fix that up and get some backcountry places going, but we don't do the things that you do in Idaho. If you want to learn how to land on the sandbar, go to McCall. There's some great folks up there who will be glad to teach you how to do that. That's different than what we're talking about here. We're talking about mortal airports with concrete runways, and they're reasonably long runways, most of them. Okay? There are certainly some, like Glenwood Springs has a 3,500-foot runway. That's a little bit of a challenge for some airplanes. It's 5,800 feet high. It's higher than the runway is long. Leadville's got a 6,000-foot runway, plenty of room for most aircraft if you do it right. If you don't wait until it's 75 or 80 degrees, which I think the highest temperature at Leadville ever is like 81 degrees or 79 degrees or something. So you don't have to worry about 90-degree temperatures at Leadville. But the density altitude is still very high. Okay? So here's a typical single-engine aircraft. This is like a 182 or maybe a Bonanza. I forget what actually used here for the example, but basically you can look at this. At 6,000 feet, density altitude, so leaving Fort Collins or leaving Denver to go to the mountains, ground roll might be 1,800 feet. You go to Aspen at 8,000 feet, density altitude. Ground roll might be 2,200 feet, so now you can see where you get the performance is going away. Then you get to Leadville at 10,000 feet, and now the ground roll is 2,800 feet. Okay, we've gone up about to what, a third, we've added at least a third to the takeoff distance required for this mythical airplane. So it makes a big difference. You have to get into the performance charts and understand what density altitude is doing for your performance, because it makes a big deal. Gross weight also affects performance, as we all know. So what we recommend is not flying more than 90% of maximum gross. So just offload some baggage or don't put as much fuel in. Things are not very far apart in the mountains. The way you get to them might be a little ways, but generally you're not going to be very far from a gas station. So don't put a full load of fuel on before you go up there. Keep the aircraft lightly loaded, as light as possible, as light as practical, and get back some of the performance that you lose as you go into the higher density altitudes. Okay? For crossing the ridges, the passes, what we recommend is at least 2,000 feet above all the, that you have a ceiling of at least 2,000 feet above the passes. Now what I'm talking about here is for the basic beginning mountain pilot. I know there are probably some backcountry folks in here who say, oh yeah, I just squeeze through there. Okay, go do that. But for the people who don't have a lot of experience in the mountains, I recommend doing this. At least a 2,000 foot terrain clearance. You want at least 1,000 foot, excuse me, you want 1,000 foot terrain clearance because we're above 10,000 feet. We want 1,000 feet below the clouds. So you need at least a 2,000 foot ceiling over the ridge that you're going to cross. Okay, yeah.
I ask a question in the middle here.
Sure.
What is your recommendation for the mixture setting on departure from a high altitude airport?
Okay, the question is what do we recommend for the mixture setting for departure from a high altitude airport? Generally what I recommend, especially at a place like Leadville, is you do a full power run-up and adjust the mixture for best power. Yeah. Okay. All right. We'll get back to this. Reported ceilings departing mountain airports. The mountain airport is going to be down in a valley. The ridges are 14,000 feet. The tops of the highest peaks. So if you're departing Leadville or let's say we're departing Aspen at 8,000 feet. If Aspen has a 5,000 foot ceiling, that only gives the bottoms of the clouds at 13,000 feet. That means everything around Aspen is shrouded in clouds. Now you can get down, down some river valleys and so on, but the tops of the ridges are all, it's good VFR down in the Aspen Valley, but it's obscured by a fair amount at the ridge level where you want to fly. So you can't, you have to make sure that you look at Aspen and say, oh yeah, it's a good VFR day. What does that mean at the mountaintop level? Okay. And a lot of times if you look at the weather at a front range airport, let's say you're departing Rocky Mountain Metro or Jeffco, the weather at Jeffco is not a good representation of what the weather is at Rollins Pass where you want to go across. The mountain weather is very different than the weather down on the eastern plains. So you can't really make a good judgment most days about what the weather is up there. It could be clear at Jeffco and it could be hailing and rain at Rollins Pass. So you have to really look at we have a lot of, and I'll talk about this in a second, but we have a lot of AWASs up in the mountains. Use those to figure out what the weather is at the ridge that you're going to cross. Okay, not using the front, especially the front range airports, because everybody comes to the front range when they go to Grand Junction and then they want to go into the mountains. Okay, those airports, the weather reporting at those airports is not a good representative of what the weather's going to be in the mountains. Okay. So like I said, some major paths have AWASs on them, thanks to the Colorado Department of Transportation. So you can get real-time weather or close to the ridgetop. Yes?
Where are those published?
Right here. Right there. Okay. So if you go to Colorado Division of Aeronautics, it's Colorado Department of Transportation, and you find Division of Aeronautics, you can download this chart. And this chart, the front of it is this, and it shows you all of the AWASs in Colorado. And on the back side of it, it had, hello, jet going through or something? It has this page, and this page lists all the AWASs, their frequencies, and all of the telephone numbers. Some of these are a little hard to get just from a standard briefing, so sometimes you just need to call them up on the phone. And it's just a standard real-time AWAS report. So that's a good way to do that. If you go to the CDOT, the Colorado Division of Aeronautics, they have an airport directory. And you can either write your name in there and they'll send you one. It's a really nice book. Of course, I didn't get any. They're not here this time, so I didn't get any. But they have a nice book. And it's a really nice airport directory, full color. It's got lots of notes about local procedures and things for various airports. So it's a good thing to pick up if you're going to come out to Colorado. Call them up, they'll send you one, or you can download it. You can download it from this site. And that book actually has these 2 pages in it. And it's updated. They're updating it, I think, once a year now. It's been every 2 years. So you can do that. And it's a good asset for those, especially if you're not very familiar with some of the airports. So I recommend you do that. Okay, so visibility and flying in the mountains. Excuse me, visibility and wind flying in the mountains. Most of the kind of flying you're going to be doing up there is by pilotage. You're going to be looking at a chart, whether it's on your your panel mount or your ForeFlight on the iPad or whatever, and then looking outside. And I mean, this is just basic pilotage from Baby Pilot 101, looking outside and navigating. Certainly, you can use, as an aside, certainly you can, and I recommend using GPS to help you with situational awareness. But basically, you're looking at the sectional chart and looking outside and navigating, picking the right drainage to go up and so on. To do that, you really need pretty good visibility. So we recommend no less than about 10 miles visibility. 10 miles visibility, in Colorado, if we get down to 10 miles visibility, we're all filing IFR. None of this 3 miles in haze clear stuff you have back here. Okay, so we really get nervous about that. But basically, if you don't have 10 miles of visibility, you can't reliably relate what you're seeing out of the windscreen and relate it to what's on the map. So 10 miles is really a good thing to do. Winds aloft top level should be no more than about 25 knots. And I'll show you an example here of how that's accentuated by the terrain. Winds aloft above 25 knots, and the turbulence gets too bad, the up and down drafts get too bad, and if you're not, especially if you're a low-time mountain pilot, I don't necessarily mean a low-time pilot, but I mean a low-time mountain pilot, you don't have a lot of experience up there, more than 25 knots, and you can get in over your head pretty easily. Okay. The winds aloft forecasts are pretty good. But also be aware of any possible worse than forecast conditions. So here's one. Read the FD carefully, the winds aloft forecast carefully, and look for wind shear. So here's some wind shear. Here we go from light and variable to, 250 at 28. We go light and variable and 250 at 28 and 3,000 feet. If you have wind shear of more than about 6 knots per 1,000 feet, you're probably going to get something around severe turbulence. So take a look at the wind shear, not just the raw wind speed, but the shear as you go from level to level. And if we look at the pilot reports that went along with this, there are actually some severe turbulence pilot reports. There's one, here's moderate chop. Here's one, the pilot report, 250 at 61. Also notice it says negative turbulence. Got lucky. Here's one, turbulence negative, but here, moderate turbulence, moderate turbulence. This is on the same day as that winds aloft forecast up there. Okay. So take a look at the winds aloft, make your decision about whether you're going to fly, and then be prepared for something worse. So a lot of times it's worse. A lot of times it's better. Make a pilot report when you get up there if you decide to go. Make a pilot report and let the rest of us know whether you made a good choice or not. We'd like to learn from your experience. So we decide whether we want to go fly. Okay? Okay, so mountain wave. Who hasn't heard about mountain wave before? So let's talk about mountain wave just to refresh your memory. Mountain wave is simply taking stable air. It has to be a stable atmosphere. And we push it up against one side of a mountain, and it gets on the other side. And what does stable air want to do when you let it go? It wants to go back down to its equilibrium level. So as it goes back down, it tends to want to oscillate. It creates what's called a standing wave. And so it's basically just a gravity wave that is oscillating as it tries to return to its equilibrium level. So that's mountain wave. That's all mountain wave is. So if you get into that, if you need to fly on a day like this, there are some things you have to worry about. First of all, mountain wave generally needs winds of about 15 knots or greater within 30 degrees of perpendicular to the barrier, whatever that barrier is. In this case, we're talking about the continental divide. So 15 knots or greater, so it doesn't take a lot of wind to get this going. But I emphasize it takes a stable atmosphere for this to happen. If there are clouds, if there's enough moisture, in the updraft, it'll cool and cause a cloud to form. And then in the downdraft, we get heating and the cloud goes away. So if we have enough moisture for that cloud, we get what are called lenticular clouds, and they simply follow the crest of the mountain wave. So it's called ACSL, alto cumulus standing lenticular. You will only see that noted in the remarks section of a METAR. Now, the only time you're going to get something added to the remarks section of a METAR is when there's a huge observe it. So you're only going to see that from airports that have controllers, basically. You know, some trained weather observer to augment the AWAS report. So it would be only the tower airports. So it would be Metro, Centennial, Buckley Air Force Base, Colorado Springs, Denver, that sort of thing. Places like Fort Collins, where I come from, we don't have an observer there. So you will never see, the AWAS can tell you that there is a cloud, it can't tell you what kind of cloud it is. Okay? So you'd only see that in the remarks section. Also, here's the updraft, here's the downdraft. Don't climb in the downdraft, climb in the updraft. Okay? Don't waste your gas trying to outclimb that 1 or 2 or 3,000 foot per minute downdraft. Use this 1 or 2 or 3,000 foot per minute updraft to climb and then go across the ridge. Make sure you've got enough altitude to go across the ridge knowing you're flying into a downdraft. So if we're going from east to west, from over here to over here, I climb over here in the updraft, I'm going to still go through this downdraft. So you've got to have enough altitude out here to be able to accept this downdraft. So sometimes you fly through it, and you get too close to the train, you say, gee, I can't do that, go back, try it again, get higher, try it again, that doesn't work, maybe try it again, that doesn't work, go home. Yeah. There are times when the downdraft is so strong that in the average aircraft you can't accept the downdraft. You get too close to the terrain. Okay? So here's a real-world increase, or a real-world example. I talked about aloft at mountaintop, no more than about 25 knots. So here's an example of why we say that. This was a student I flew with a couple of years ago in a Cessna 182, the G1000 on it. We had the wind direction and speed on the glass cockpit. We did the weather briefing before we launched from Metro or Jeffco, and he said, well, the wind's forecast to be northwest of 28 knots. I said, okay, what are you going to do? He said, well, let's go over 1,000 feet higher than we normally would. I said, fine, let's go find out what happened. So we get in the 182 and we motor up to Rollins Pass, and we're at 13,500 feet. Normally you could cross at about 12.5. 5 miles away from the ridge, on the east side of the ridge, the winds were 28 knots, pretty much what the forecast said. We get over the ridge, and the wind value was 49 knots. We get 5 miles on the other side of the ridge, the wind was 23 knots. Okay? So what happened? Anybody ever heard of Bernoulli effect? Constricting the airflow, speeds up. That's exactly what happens here. So as you're going across these ridges, that's why we say no more than 25 knots, because it's going to increase sometimes, in this case, almost 2x. All right? So that's why we say keep the wind down if you're going to do mountain flying. Also, we had smooth air. It was nice and smooth going across. We are in what's called laminar flow. That is, it was nice and smooth going across. Airplane exactly the same, 1,000 feet below us, same time. They made a pilot report and we were listening as we were going across the bridge. They were 1,000 feet below us, moderate turbulence. So they were in the mechanical turbulence down lower. It was no longer laminar flow. So if the winds are strong, you may want to go across a little bit higher, quite a bit higher, to hopefully, sometimes it doesn't work, but a lot of times it will. You'll stay in the laminar flow and you'll have a nice ride. You get down too close to the train and things started getting mixed up, and suddenly you can't, you have things bouncing around the cabin all the time from the turbulence. Okay? So here's some examples of lenticulars, and it's simply, there's the mountain wave and the lenticulars coming off the Continental Divide. They're just the lens-shaped clouds that go across there. Here's some smoke that got trained in a mountain wave. This is smoke from a forest fire west of Boulder, Colorado. The wind ground when they were fighting this fire were about 50 knots. Bad fire, burned a bunch of houses and so on. This is 4, 5, 6 years ago. But you can clearly see the up and down drafts in the mountain wave outlined by the fire. Here we've got a stacked lenticular, and right underneath this one is Long's Peak. It's a 14er right underneath here. And sometimes single peaks will create their own mountain wave. In this case, we've got a nice mountain wave gives us in Colorado some really nice sunsets, because we have these nice views of the clouds. They're very stable looking. They're not very stable, but they're very stable looking. So we get some nice sunsets like this one. Here's another one. We've got lenticulars right in here, lenticular right here and here. Now, a lot of times, if it's under the right conditions, the mountain wave will extend way downrange from the barrier. In this case, this is off the Appalachians, and you can see these cloud streets, these streaks of clouds. Those are the tops of each wave of the lenticular. And they go all the way out across, what are we across, Delaware and Maryland and off the coast. So going out, people from back east, what is this, 200 miles or so, 250 miles? A lot of times you can see them coming across Colorado, and they'll go all the way out to the Kansas border. It's about 250 miles or so. You can see them all the way across from the Sierra Nevada. You can see them all the way across the state of Nevada. So that's 200-300 miles under the right conditions with enough moisture to show all the clouds in the wave. So they can extend downrange a long way and create a lot of havoc for flying. There we go. Here's another one. This is off of, here's Farmington, New Mexico. FNM is Farmington down here. And this is coming off the Southern Rockies, and it's going a fair ways across New Mexico. So even though you get away from the mountains, especially on the east side of the mountains, that doesn't necessarily mean you're not affected by the mountain wave, because it can go a long way downstream. So we have lenticular clouds if there's enough moisture. The wave is there whether you've got the moisture to create the cloud or not. Also underneath the crest is an interesting thing called a rotor. And a rotor is simply a sort of a horizontal vortex that's created as the wave goes over the stable layer underneath it, and it causes a rotation underneath the crest of each wave. Bad place to be. Certainly moderate turbulence, probably severe turbulence. Okay, so this is definitely an area to stay away from. Tends to be about mountaintop level or slightly below. So in Colorado, the rotors tend to be in the 13,000 foot, maybe 12,000 foot, depending on where you're at exactly. But places to avoid, this is a place to avoid. So if you're going to climb in the updraft here, but don't get over into the rotor. Use the updraft here and stay away from this area here, because it's very likely to be severe. There we go. Here's a picture of some. They look kind of benign. Trust me, they're not. Most of the time you can sit there and watch them real time and just watch them rotate. Anytime you see that, bad day to go fly.
You say they're horizontal?
Yes, it's a horizontal tube, basically. Yeah. So here's some rotor clouds, and again, they don't look. They're called fractocumulus. If they look bumpy, they are bumpy, probably, most cases. In this case, they're really bumpy, so you want to stay out of those. The nice thing about them is they show you where the rotor is. So here's a combination of a lenticular and a rotor cloud underneath. So we have a rotor cloud here, the lenticular above. Here's our rotor cloud. Looks like sort of cotton candy being thrown about. Here's another one. This has got several things going on in it. Fortunately, I was firmly planted on the ground when I took this picture. But you can see a bunch of things happening here. First of all, we got a contrail that's been entrained in the mountain wave up high. This area right in here, the big cloud, is a rotor cloud. So that's this guy here. And then we've got, what do we have there? We've got blowing snow coming across that ridge. So especially crested snow, it probably takes 30 or 40 knots to get snow to blow like that. So anytime you see blowing snow in the mountains, it's probably more wind than you want to fly in. Video? Here we go. So here you can see this is sped up about 30 times, but it gives you an idea of what you're looking for, what you're looking at. So we have the streets of rotor clouds. There's one here, there's one here, there's one that wants to form right in here. So these are all the rotor clouds right in here, and you can see the rotating moment in them. And this one right in the middle here, there's not quite enough moisture to keep the cloud there, so it forms and dissipates, forms and dissipates. So, but that's what the rotors look like. Bad place to be. And clearly you can see, even if we slowed that down, it would be the place you'd want to be at. Yeah.
Climbing through that.
Climbing through it. My cohort in crime over here for mountain flying let out a big guffaw. No, you don't want to do that, because it is potential severe turbulence. So what you want to do is find the updraft of the wave and stay out of this. Find the, look for the crest, look for the lenticulars if you can find them, and find the updraft and climb there. Through that or descending through that is a guaranteed bad ride. Yeah. Or damage, yeah, exactly. Yeah, there was a Sierra Wave project back in the 50s when they were exploring mountain wave. We didn't know anything about mountain wave then, and they were flying off the Sierra Nevada. The guy was up in a glider, and his report was, when I woke up, the airplane was not there anymore. And so he parachuted down, the airplane was destroyed, the glider was destroyed, and they found the G meter, and it was like 9 Gs or something like that, and he flew through rotor. So it's really not a place to be, so you really don't want to be climbing through it or descending through it. Yes?
So there will always be a cloud.
There will not always be a cloud. There will not always be a cloud. That's the problem. If there's a cloud, that's a good thing, but they're not always there. Okay? Okay. Blowing snow, we talked about blowing snow. If you see a day like this, and we have these pretty often in the wintertime, you see blowing snow like that, park the airplane, go drink beer, rent a car, go to Aspen, whatever you want to do, but don't get in an airplane. Bad deal. We already talked about that one. There we go. On Aviation Weather Center, there is a graphical turbulence forecast now, and it's a pretty good indication where you're likely to find turbulence. At the top, you can select whether it's where you want to look at mountain wave or clear air turbulence or combined, and you can select what type of what weight of aircraft you have, whether it's light, medium, or heavy, and it will, down at the bottom is a scale of what's called eddy dissipation rate. And in simple terms, that's basically how bad you're going to get bumped around. But it's a sliding scale. Notice it says light, moderate, severe, extreme turbulence. If you change the aircraft, that is the weight of your aircraft, from light to heavy or vice versa, the map doesn't change, but that scale changes. Right? So if you're flying a heavy aircraft, if you're flying a 747, 747 is going to have a much different environment or a much different reaction to the turbulence than somebody flying a light aircraft. So this will give you some idea of how the turbulence that's there might affect your specific aircraft. So most of us are probably going to have light turbulence in there. I saw a pilot report a couple of years ago of a 747 descending into Denver from the southwest. They reported severe turbulence. I'm going to keep the Baron on the ground, right? Bad idea. Also, how many are using NextRad in the aircraft, whether it's ADS-B or XM or whatever? All right, works fine out here. Remember that it doesn't see through granite. Okay? So when you're flying in the west around the mountains, whether it's Colorado or Wyoming or any place else out there, remember that the radar sites are sited, may be blinded a little bit by the mountains. In this case, for Denver, I took this a couple of days ago. We got a lot of thunderstorms out on the eastern plains, but there's not a lot up in the mountains. You can see Aspen right in here. There's not a lot of return up there, and it's also relatively light return. The Denver radar cannot see below about flight level 230 over Aspen. So the weather's got to be pretty tall for it to be seen if it's over the central Rockies. A lot of times in the wintertime, though, the systems are much lower. The tops of the precipitation are much lower. So there's stuff going on that the radar can't see. So even though you might have a clear radar screen on ForeFlight or whatever you're using, the weather, that doesn't necessarily mean the weather's good up there. There could be some showers up there that the radar simply can't see. Now there's 4 radar sites we really care about in Colorado. One is Denver at Front Range Airport, just south of the big airport. There's one at Pueblo. There's one at Grand Junction on the west slope. And then there's Cheyenne, Wyoming. And I use Cheyenne, Wyoming a lot because it's closer to Fort Collins than the Denver radar. And it also sees to the southwest into the Colorado Rockies. So those 4 radars, if you're coming out west into our state, which you really care about for mountain flying or getting an idea of what's going on in the mountains. But again, with the understanding that whatever you're seeing may not be representative of what's there because the radar can't see down on the hills. Wind through passes, we already talked about the Bernoulli and how it affects wind going across the ridge. Same thing happens going through passes. So if you're going through a really narrow pass, the wind is going to increase going through there. So take note of that. Fly around it. If the wind is very strong, you probably want to go around this ridge or fly over it, not down into that pass. Here's one. This is, for those of you familiar with Colorado, this is Taylor Reservoir, Taylor Park. And again, it's a constricted airflow coming through that gap coming up from Gunnison. And over the top, if we have southwesterly winds, we've got the wind through the gap, and then we've got wind coming over the mountain. So over the mountain, we've got downdraft on this side, the side the airplane is at here, and turbulence. A lot of times, what will happen if you look at rocks in a stream, and as the stream goes by, you can see the eddies that form behind the rocks. Same thing happens here. So you can actually have these little eddies forming behind the ridge or behind this little mountain here. And if you need to leave yourself an out, if you're going to fly up close to that terrain, sometimes those eddies will actually push you into the terrain, right? Because it's swirling around and it will actually push you into the mountain, which is a bad deal if you're in Civil Air Patrol trying to do a search up there and you're up close to the terrain. So be careful about that. There we go. Also, wind around the runway environment. This is at Salida Airport, and we're looking at the Collegiate Peaks, a bunch of 14ers off to the right-hand side here. But the wind coming across down valley here, we're looking to the what is this, runway 24? So we're looking to the southwest. There's about a 200-foot drop right off the end of the runway. So what's the wind going to do as it goes across there? It's going to be a downdraft, right? So big downdraft. So what do? Well, if there's enough wind to make this be a problem, there's a lot of wind coming down the runway, so you don't need a lot of runway. So you don't have to land right on the end of the runway. So aim a couple thousand feet down the runway and just do a normal approach. People say, "Oh, well, I'm going to do a short field approach and all this kind of stuff." No, just do a normal approach 2,000 feet down the runway if you've got a long enough runway. And that way you fly over most of that downdraft, not through it if you're landing right on the end of the runway. Now, if it's a short runway like Glenwood Springs, you got to do that. But Glenwood Springs doesn't have a drop-off like this. So another problem you have at some airports like Leadville, this is looking north at Leadville on 3-4, is a bunch of trees right along the runway. If we have a westerly flow, we're looking north, so if we have the flow going from left to right, what happens to the wind as it goes across those 60-foot trees? Turbulence, exactly, and it turns out at Leadville, it puts a downdraft right over the runway. And it's actually caused accidents and a lot of heart palpitations for those that didn't hit the ground. Okay? So it simply comes across and it curls, but that downdraft tends to be right over the runway. So local knowledge here is a good thing. Go with a flight instructor and they'll help you pick these things out. Orographic lifting, again in a stable atmosphere, the western side or the windward side, if there's enough moisture, a lot of times we'll have what's called a cap cloud. It'll be bad weather on the west slope, west side of the ridge, and it'll be good weather on the front range. And what we will see from the front range is called a Foehn or a cap cloud, and it looks something like this. Okay, so and here we're looking into the San Luis Valley. This is looking back toward the southwest. So we have the moisture of the valley being pushed up slope, and then as it comes down slope on the east side of the slope, it dissipates. So it's IFR looking into the picture, but it's good VFR over here. Okay. There we go. Same place, turn the other way, and you see how as it goes down slope, the clouds are dissipating, but it's IFR on the windward side of the ridge. Also, there's a bunch of things going on in this picture. First of all, we have stable air right here, right? We're displacing it, but it wants to come back down. What's happening off in the distance here? What's happening up there? Are those stable clouds? No, we got thunderstorms building. So we've actually got two different air masses. We've got the nice stable air where we're at, flying here. Turns out I was CAP mission looking for somebody who crashed a Mooney in a thunderstorm the night before. Go figure. But over the Collegiate Peaks to the north, we've got thunderstorms building. Okay? So we got actually two different air masses here doing different things. The clouds will tell you a lot, especially about mountain flying. Here's another one. This is Rawlins Pass, looking north. So the air is being pushed from the left-hand side of the picture to the right-hand side of the picture. So over Winter Park, we've got IFR conditions over the ski area, and on the eastern slope, the clouds are dissipating, and we've got good VFR. And here's what it looks like from the ground, in this case from Fort Collins, looking west. So we have a couple of things here. First of all, we have the cap cloud. That's this stuff here. And it's a stable atmosphere. You can tell because there's not a lot of vertical development. Okay? But we've also got these little guys right here. What do you suppose it is? There's the rotor. There's your sign. Don't go there. Bad idea. If it's unstable, we displace the air. Where does it want to keep going? It wants to keep going up, right? So if we displace the air this time of year, when it's usually an unstable atmosphere, then we get thunderstorms starting to develop. So one of the rules of thumb is in and out of the mountains before noon, because this is what happens about 11 or 12 o'clock in the afternoon. Now, a lot of times these don't make it all the way to the front range. There's enough instability and enough moisture to get them going, but once they move out into the plains are much drier time, and the thunderstorms dissipate. So we'll see a lot of lightning and bad weather over the front range, and I'll sit on my deck and say, "Oh, gee, it's going to come." "Oh, no, it's not. It's gone." "Yes, sir."
Would you consider switching to the microphone? That will help my keep breaking in and out.
I can do. Shall we do that, guys? I actually don't have it up here.
Thank you.
2, 3. Good. Hello, test. 1, 2, 3, 4. 1, 2, 3, 4. Hello, test. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Hello. There we go. How's that? Is that better? Okay. So we have orographic lifting, unstable atmosphere, thunderstorms develop in and out of the mountains before noon. Otherwise, you got this to contend with. Here we have looking south now, so this is on the back side of the Continental Divide, and we've got enough moisture. You see, there's not in this case, there's not a lot of vertical development, but there's enough instability simply from the orographic lifting to get some cumulus built up. Now, also notice that there's not a lot of distance between the terrain and the mountains, or the terrain and the clouds. So this is probably something you're going to have to go around, not underneath, to be able to safely get across the ridges. So we have the early winds pushing the moisture upslope and creating the cumulus buildup. The altitude of the line of the top of the trees. The tree line in Colorado is about 11,600 feet. That's what you're talking about, right? Okay. Yeah, the tree line in Colorado is about 11,600. So almost anywhere in Colorado, you see the tree line, that's 11,600. Good altimeter. Don't depend on that, though. Here's another one, basically the same place looking north. We've got the westerlies pushing the wind upslope. This one actually turned into a thunderstorm that kept moving, and it's starting to precipitate. So if we have enough instability and enough moisture, we get thunderstorms. And if there's support once they get out into the eastern plains, then we'll continue the thunderstorms out there. But a lot of times they stop at the foothills just west of Denver. There we go. Also, how many fly underneath Virga? Okay, let me ask you to rethink that, especially when you come out here. Here's a hailstorm, and I stole this off our local Channel 9 video the other day. This is a hailstorm in Conifer, which is at 8,300 feet. Now, the reason I bring this up is that a lot of times, I flew through a little rain coming into Green Bay the other day, yesterday, and I probably wouldn't do that, especially up close to the base of the clouds in Colorado. The reason is that in Colorado, especially in the mountains, if you're out on the eastern plains, the hail's going to have plenty of time most of the time to melt, and so you just get rain out of it. In the mountains, that's not the case. This is 3,000 feet above the Front Range. So if this storm had been over downtown Denver, chances are they would have only gotten rain. But in the mountains, it's falling much. It doesn't have nearly as far to fall, and so you get hail. So be very careful about flying in rain at the higher altitudes up in the mountains, because a lot of times the hail hasn't had a chance to melt. Now, it's not big hail. They rarely get big hail up there, but they get a lot of pea-sized hail and graupel and stuff like that. While it won't probably damage the airplane very much, it'll really screw up your paint job, and it'll be really noisy. So be careful with that. Also, one of the things that happens is when we get what's called upslope, that is, we get a moist advection coming into the Front Range from the east or southeast, we'll get bad weather down below on the Front Range. But the depth of the upslope flow is not enough to get it over the Continental Divide. So a lot of times you can file IFR out of the Front Range and have good VFR up in the mountains. Okay, so they'll be skiing in shorts and T-shirts up in the mountains, and we'll be slogging around in drizzle down on the Front Range. So it's sort of the opposite of what we talked about before. If it looks like this out the windscreen, you are doing something wrong. Be very careful. Turn around before it gets that bad. Weather deteriorating en route. A lot of times going back where you came from is the best way to go. Divert to a nearby airport. If you get yourself into a fix and you have to land under control. Don't just give up. If you land under control, you have about a 90% chance of surviving the accident. If you land out of control, stall spin or whatever, you have about a 90% chance of dying. Don't do the dying part. Okay. I know you're there. There we go. After landing, if you have a crash, you have an engine failure, have to land because of weather or whatever, please stay with the airplane. Time and time again, CAP has found people who said, oh, gee, there's a house just down there. And we find them 100 yards away from the airplane, after we found the airplane, and they're face down and got hypothermia and they died. So stay with the airplane. It's a lot easier to see an airplane than it is to see a single person, especially if they're in the trees. So stay with the airplane. Keep warm and dry. Turn the ELT on. If you did a good landing, the ELT might not have gone off. So turn the ELT on and let your rescuers turn it off. Don't flip the switch on and off. There are people out there looking for you even at night. So let your rescuers turn the ELT off. And of course, try and signal somebody, your favorite signaling device, whatever that happens to be. This is old data, but basically, if you've got a flight plan without an ELT, 55 hours to be located. If you've got an ELT and you file the flight plan, half a day maybe. If you don't have a flight plan and you don't have a working ELT, and ELTs are notoriously bad in actual accidents where you need them, but if you don't have a flight plan and nobody knows where you're at, and you go down and the ELT doesn't work, hunters find you in the next hunting season. Hikers find you in the spring. So file a flight plan, have a good ELT, activate it when you get on the ground. Also, everybody on board the aircraft ought to be wearing clothing to survive in the terrain over which you're flying. So no flip-flops and shorts to go on a mountain flight. Make sure everybody's got enough clothing on so they can survive if you go down over any of the terrain you're flying over. Hello. There we go. There we go. This is a National Weather Service bulletin from Hazardous Weather Outlook from August 2015, 2 years ago, August. And if you look down here, the system will be cold enough for some mixed rain and snow over the higher foothills and mountains where up to 2 inches of snow is possible. August. It snows up there. And in fact, it did. This is Trail Ridge Road up in Rocky Mountain National Park. So it can snow any time of the year up in the mountains. Be prepared. And that's it, folks. Any questions? Any other questions? Thank you. Thank you. Any other questions? Yes? That's a tough question. The question is, how low do you have to be below a buildup to worry about not have to worry about being sucked up into it? That's a tough question because it depends on how strong the updraft is, basically. And I don't think I could give you a reasonable answer for that. Updrafts are good if it's just puffy cumulus. Updrafts are good because they tell you, or cumulus is good because it tells you where the updraft is, so you can use that to climb under. But if it's precipitating, then it becomes downdraft, and so. But again, to answer your question, I'm not sure I could answer that. It just depends on how strong the updraft is, and leave yourself an out. Any other questions? Yes, sir. A copy of which? I don't know if are these being posted somewhere. Okay, on the FAA YouTube channel. Check with one of the FAA folks when we're done here. Thanks again.
Thank you. All right. Thank you, Bill.